These are repeatedly asked JEE advanced questions from mole concept, or you can say some basic concepts of chemistry. See the first question. Same mass of glucose C6H12O6 and acetic acid contain different options they gave here. Observe it now. For example, if I take here glucose molecular mass, if you observe it, see here, glucose molecular mass or glucose molar mass, we can consider it as, we know it is 180. Molar mass of glucose, it is 180, and followed by the molar mass of acetic acid. Acetic acid molar mass, whose molar mass is 60. Or you can say molar mass of glucose by molar mass of acetic acid. How much you will get? Is equal to 180 by 60, which is equal to 3. So if same mass, that is glucose molar mass 180, acetic acid molar mass 60. So with ratio 180 by 60, we are getting 3 here. Similarly, acetic acid formula, it is, if I add both C2H4O2, if I multiply with 3, here we are going to get C6H12O6. So the acetic acid molar mass is 3 times, or you can say glucose molar mass is 3 times of acetic acid molar mass. So now if with this information, if we correlate here, if A moles of, if I take A moles of acetic acid, and you can say here A by 3 moles, that is nothing but A by 3 moles of glucose. If A moles of CH3 is, they gave here same mass, remember they gave here same mass. So if mass is same, then which is deciding factor? Same mass is given, then deciding factor is here molecular mass. So if A moles of CH3COOH is given, A by 3 moles of glucose, then hence, then automatically you can say here, hence each atom will be same. Hence each atom will be same in both. So here answer it is A, B, C, D, all of the above you can say A, B, C, D. Because how we can relate? If the same mass of glucose acetic acid given, then it depends on molar mass. Molar mass of acetic acid is 1 by 3 of glucose. So automatically you can say, even formula you see, number of atoms, how we can say? Glucose number of atom 3 times of acetic acid number of atoms. So both will be balanced, and overall you will get same number of atoms. Next, calculate percentage mole and percentage of hydrogen in mixture of H2O2 if average molecular mass of mixture is 14. So here how we need to proceed further? See, first I am taking here, first I am calculating percentage mole of H2. Percentage mole of H2 is equal to, what I can write here, if percentage, I can say moles of H2, here I am first referring 100 moles total. I am referring here 100 moles total. So in that X moles, that is hydrogen moles, then 100 minus X moles, 100 minus X moles, that is oxygen, 100 minus X oxygen. So now with this information, X into molecular weight of hydrogen 2 plus 100 minus X moles of oxygen present into molecular weight of oxygen is 32 by overall mass, how much? 100 moles overall, 100 moles. So if you do calculation here, you will get 60% mole of H2. 60% mole of H2 in given 100. So here with this information, here what you can say, 60% by mole of hydrogen is correct. Then proceeding further, percentage by mass of H2. So how we need to find? Mass of H2 by total mass of H2 plus O2 into 100. Simple, once if you know the method. Mass of H2, how to calculate? Out of 100 grams or out of 100 moles, 60 moles hydrogen. 60 moles meaning I'm taking 60 into 2 by total mass of H2. How we will calculate? 60 moles into 2 total mass of H2 plus remaining 60 moles of H2 meaning 40 moles of oxygen into 32 into 100. Because how we calculate mass? Mass is equal to moles into molar mass. So if you do here calculation, here you will get 8.757 by mass. So even C also correct for the given question. Next, moving further, solutions containing 23 grams of HCOOH is R. See here, first option I am taking directly. See, first option I am explaining in detail, remaining automatically follows same pattern. Here I am taking 70% W by V HCOOH meaning 70 gram is in 100 ml solution. 70 gram is 100 ml solution. Now weight of solution, how to find? Weight of solution is equal to density into volume. 100 ml solution, right? It is density into volume. So which is equal to density is 1.4, volume is 100 ml, which is equal to 140 gram. 140 gram. So here according to given question, given that 140 gram solution, 140 gram solution contains 70 grams HCOOH. It is given in the question like information. But if it is 46 grams of solution, 46 grams of solution contains, so what we do? 70 by 140 into 46, so which is equal to 23 grams of HCOOH. The solutions containing 23 grams of HCOOH. So first solution contains 23 grams of HCOOH. Similarly, if you proceed further, I am proceeding further similarly for option B also here. So direct I am finding now. So weight of HCOOH, what they gave in the question? 50 grams of 10 molar HCOOH solution, density also given. Density also given. So 50 grams of 10 molar, yes, 10 molar HCOOH solution. So how we can calculate here? Into that is 1, 10 molar, because HCOOH solution they mentioned. So then followed by 46, because 46 overall, and then 46 molar mass of HCOOH. Overall, if you do here 23 grams, you will get. Why we are taking 50? Because we are calculating weight of HCOOH by using molarity. Molarity formula already we know. Molarity formula already we know. Directly I wrote here. See molarity formula. What is molarity formula? Number of moles of solute by volume of solution in liters. It is molarity formula. So just by using which we calculated weight of HCOOH. Next. So here also there is correct answer 23. So B also correct answer here. Similarly, you see next option C. Here also weight of HCOOH is equal to 46. 50 grams of 25% W by W HCOOH. So 25% HCOOH. So see now 25% of 50 grams. 25% of 50 grams. So here directly you can write here 12.5 grams. So here it's not giving correct answer. Then similarly 46 grams of 5 molar HCO solution. It's same like option B. Same like option B. So here I am writing weight of HCOOH. Weight of HCOOH is equal to same like option B type. Formula also given. So here 5 into, because they mentioned 5 molar. So that's why I'm multiplying with that 96. You will get here 10.58 grams. So overall answer should be here option A and option B. See here we elaborated. How we can elaborate number of moles of solute? Given weight by molecular weight into volume in liters. You can elaborate even formula like this. That's what we, here we calculated W value. in question. Next question. Incorrect statements regarding 2 molar MgCl2 solution. Incorrect statements. See here. So how molality of Cl minus they mention. First I am starting with option A. 2 molar MgCl2. Information given. See 2 molar MgCl2 meaning 2 molar MgCl2. So 2 moles of MgCl2. So 2 moles of MgCl2, that is which is equal to 190 gram, which is equal to 190 gram. So 2 moles, 190 grams in 1090 grams solution. 1090 grams solution. How you are getting a solution? 190 in 1090 grams of solution we mentioned, or you can write, how you can write? It is in 900 grams solvent. Properly observe it. Solution or solvent. How you are getting 1090? Here weight of solution is equal to density into volume. So density how much here it is? Given as 1.09. Volume is 2 moles in liter, right? So 2 mole per liter. Molarity meaning, so 1000 ml, that gives 1090 or 900 grams of solvent. Anyway you can interpret it. Now molality of MgCl2 is equal to 2 moles per weight of solvent in kg. It is in grams, so that's why I am converting into kg. So overall you will get here 2.21 liters. But what we need to calculate here? Molality of Cl minus. So molality of Cl minus is equal to 2 into 2.21. Sorry, not here, it is molal. 2.21 is equal to 4.41. 4.41, or you can say 4.44 molal. Overall answer. So any option matching here? So first option is correct. Then they're asking about incorrect. So next option B, if you see, observe option B. So here moles of H2O. First you find moles of H2O in this case. 900 grams of water present plus 18 is molecular weight. Moles of H2O, that is 50 moles. So then mole fraction of MgCl2. Moles of MgCl2 by total moles, so 50 plus 2 is equal to 0.038. Next, C option. They're asking here concentration in W by V. How we calculate? Weight of solute 190 grams by volume of solution into 100, which is equal to 19%. Similarly, concentration in ppm. How we do? Weight of solute by weight of solution into million, that is 10 power 6. So here you will get 17 into 10 power 4. So incorrect options. First you see the answers here. 17 into 10 power 4, 19%, 0.038. See the solution clearly here. 0.038, and then finally 4.44. So incorrect options here. According to calculations what we did. Option B is incorrect. Option D is incorrect. Remaining correct answers according to calculation. Next, 100 ml of 0.06 molar calcium nitrate is added to 50 ml of 0.06 Na2C2O4. Select the incorrect options. Select the correct options. So now first you calculate number of moles of calcium nitrate. Number of moles of calcium nitrate, how you will get? Molarity into volume. Volume in liters we have to take. So molarity is 0.06, 0.1, 0.06 and 0.1 liter it is. Okay. So here 0.06, that is given molarity. So if you use calculation, then here you will get 0.006 moles. Similarly, you calculate moles of Na2C2O4. Na2C2O4. Sodium oxalate. So here molarity how much? 0.06 and then 0.05 liters. I'm converting into liters. So now if you convert into liters, here you will get 0.003 moles. That's what they gave in the question. Now first you write the reaction. Now after knowing this information, you write the reaction 0.006 moles and 0.003 moles. If you frame reaction here, if you're framing reaction, let us see calcium nitrate as well as I'm framing reaction. See calcium nitrate CaNO3 twice plus Na2C2O4 calcium oxalate. So sodium oxalate giving calcium oxalate CaC2O4 plus NaNO3. NaNO3, that is 2 NaNO3. Now it is perfectly balanced reaction. After balancing the reaction, so first you observe and find LR first. Find limiting reagent. We know already the trick how to find limiting reagent. Given moles of calcium nitrate 0.006 by 1. Here 0.003 by 1. So which is limiting reagent? Here limiting reagent, the one which is having lower value is limiting reagent. So here we identified limiting reagent is sodium Na2C2O4. Okay. So now after knowing limiting reagent, if it is completely utilized in the reaction, here only 0.003 utilized and then remaining 0.003 left. After completion of reaction, it is left. So now if you find here molality of after the reaction, how much amount of calcium oxalate will get precipitated? Okay. So first of all, 1 mole of sodium oxalate gives 1 mole of calcium oxalate. Sodium oxalate will give 1 mole of calcium oxalate. So here what you can specify? Here you will get 0.003 amount of calcium C2O4. This much amount you will get. So after the reaction is complete, 0.003 moles of calcium oxalate will get precipitated. According to first option. Yes, it is correct. Second option, after the reaction is complete, 0.003 molarity of Ca+2 will remain in excess. 0.003 like molarity they mention here. So let us see here. Molarity of calcium nitrate is equal to after the reaction. Molarity is equal to, so how many moles left? 0.003 moles left. Total volume how much? 100 ml here, 50 ml there. Total 150 ml. So if it is ml, you have to convert into like liters. And then overall, if you see here, how much we are getting? Overall after the calculation, and you correlate with the option. After the calculation, we are getting 0.02. But in option, what they gave? In option, they gave 0.003. So that is incorrect option. C option, Na2C2O4 limiting reagent. CaNO3 is excess reagent. Yes, it is correct. So after knowing all these values, now if you see the correct options here. So A, C, D correct. A, C, D correct, because option B not satisfying. They mentioned 0.003 molar Ca+2, but here you see 0.02 molar CaNO3 twice present. Next question. A sample of calcium chloride. See the question. A sample of a mixture of CaCl2 and NaCl weighing 4.44 grams was treated to precipitate all the Ca as CaCO3. So here like POAC based question. If you did not see POAC lecture, once you see previous lecture, POAC based lecture, that is important. So here they mention all the Ca as CaCO3. They mention all calcium is converted into CaCO3. So then you can apply POAC for whenever reaction is unpredictable, difficult to balance, and simple reaction you can follow, simple method, apply POAC for calcium atoms. Why we are applying for POAC for calcium atom? Because they mention treated to precipitate all the calcium as CaCO3, means all calcium atoms convert into CaCO3. So here first they mentioned CaCl2, here it is converted into CaCO3, then it is converted into CaO. That's what they mentioned. So here number of calcium atoms in CaCO3 is equal to number of calcium atoms in CaO. We know that. So here you can write number of moles of CaCl2, you can mention it as number of moles of CaO, because calcium atoms are exactly same. Exactly same. So then number of CaCl2 is equal to moles, number of moles of CaO. So here moles of CaO is equal to 1.12 by, because they mentioned 1.12 grams of CaO by 56 molar mass of it. So you will get here 0.02. So here moles of CaCl2 is equal to 0.02. Then weight of CaCl2. How to calculate? Moles into its molecular weight. CaCl2 molecular weight 111. 2.22 grams is answer. So next, if we see here question, mixture contains 50% NaCl. So how to get this information? Mixture contains 50% NaCl, meaning if CaCl2 2.22%. So here 2.22 is CaCl2, right? Then what about NaCl here? Then NaCl should be 2.22. NaCl should be 2.22. So both are in 50%. Why? Both are equal to 4.44 they mentioned. Both are equal to 4.44 grams. So automatically here 50% of NaCl present in the mixture, then followed by mass of CaCl2 is 2.22. These two are correct options for this. Okay. Next, the reaction 2C plus O2 giving 2CO is carried out by taking 24 grams of carbon, 96 grams of O2. How many grams of carbon monoxide are formed? So see how to calculate. Here in this reaction, 2 carbon plus O2, that is giving 2CO, reaction given in the question. So moles of carbon is equal to 24 by 12. Moles of carbon is equal to 24 by 12. Just atomic given mass by atomic mass. 24 grams of carbon they mentioned. So here it is 2 moles. And moles of oxygen is equal to 96 by 32, which is 3 moles. 3 moles given. So now you easily can find which is limiting reagent. In this case, based on the trick, what we use, given moles per stoichiometric coefficient, if we do, whichever is the lowest value, that is limiting reagent. So here based on given equation, so here oxygen is limiting reagent, sorry, oxygen is excess reagent, and then carbon is limiting reagent. Question is how many grams of CO are formed? How many grams of CO are formed? So which is mole of carbon, that is 2 by 2 if you 1, here 3 by 1, okay. Limiting reagent is carbon. So how to find now? Based on carbon you have to find 2 moles of CO will give 2 moles of, what they are asking, how many grams of, okay, how many grams of reactant left in excess? Okay. See here, O2 excess reagent we know here, right? If O2 is excess reagent, we know 2 moles of carbon react with 1 mole of oxygen. 1 mole of oxygen. But how many moles given? 2 moles of carbon only given, 3 moles of oxygen given. So 1 mole of oxygen, O2. So then how many moles left here? So then moles of oxygen left is equal to moles of O2 left is equal to 3 moles given minus 1 mole reacted, 1 mole reacted, So left is equal to 2 moles. If 2 moles of O2, then how we can write it? 2 moles into 32, 64 grams. So 64 grams is answer here in the given question. So answer option A is correct answer here. You observe the solution, whatever we mentioned. Next, how many extra moles of limiting reagent should be taken so that nothing is left at the end of reaction? Nothing is left at the end of reaction. So here extra moles of oxygen, how many extra moles of limiting reagent should be taken so that nothing is left at the end of the reaction? Yes. See now. So left over, how many moles left here? 2 moles left. 2 moles left. Already 2 moles of carbon present. So here according to given question, 2 moles of carbon can react with 1 mole of O2. 1 mole of O2. But in beginning we took 3 moles of O2 because that is given. 3 moles of O2. So how many moles we need here total to react with 3 moles of O2? So 2 moles of carbon, so 2 into 3 by 1, that is 6 moles we need. So 2 moles of carbon reacts with 2 moles of okay, see. So 6 moles of carbon required. So there is nothing left. The 3 moles of oxygen will be completely utilized. 6 moles of oxygen required. So how many we took? 6 moles minus 2 moles present given. So more, how many moles required? 4 moles more required. 4 moles required, that is extra. See how we wrote, observe it once again. 2 moles of carbon react with 1 mole of oxygen. Here with us 3 moles of oxygen. So to react with 3 moles, how many moles of carbon required? 6 moles required. With us how many moles? 2 moles. So 6 moles required, but present available only 2 moles. So how many extra moles we need? 4 moles extra we need. So answer is here C. Option C, that is 4 moles required extra. Next question. If all the oxygen atoms from a mixture of O2, mixture of 2 moles of H2P2O7, 54 grams of H2O, 98 grams of H2O are taken and then converted into ozone, the number of moles of ozone gas formed will be. So we need to find here number of moles of ozone gas will be. Okay, a simple question it is. So total moles of oxygen atoms, how many? So here they gave 2 moles of H2P2O7 plus 54 grams of H2O plus 98 grams H2SO4. So here 2 moles of H2P2O7. How many moles of oxygen atoms present here? How many moles of oxygen atoms here? 14 moles of oxygen present. Plus, see 54 grams of H2O meaning how many moles? 54 by 18, which is 3 moles. So 3 moles, because only it contains one oxygen atom, 3 moles of oxygen present. See 98 grams of H2SO4 meaning how many moles? 2 moles of H2SO4 because molecular weight is 49. So 2 moles, each mole contains 4 oxygen atoms. So here overall you will get 8 moles of oxygen. So total how many moles we have? Total moles of oxygen is equal to how many? 25 moles overall here moles. So 25, 21, 25. Here how many moles? 2 moles, right? 2 into 4, 8, okay. So 14 here 3 and 98 grams of H2SO4. So that is 2 moles. Just a minute, what is the question here? If all oxygen atoms from a mixture of 2 moles of H2P2O7 and 54 grams of H2O, 54 grams of H2O, we know that is 3 moles, so 3 oxygen atoms, and 98 grams of H2SO4. Oh, sorry, 98 grams, it is 1 mole only, right? It is here, it is 1 mole. 98 is molecular weight of H2SO4, so 1 mole. So here what we can write? Here only 4 moles. So overall number of oxygen atoms here in the given question 21 moles of oxygen atom present, 21 moles. So then how to calculate moles of O3? Moles of O3, 1 mole require 3 oxygen atoms, so 21 by 3, each mole require 3 oxygen atoms. So here 7 moles is the answer. 7 moles is the correct answer for this. Next, the number of moles of iron in a mixture of 144 grams FeO and 320 grams of Fe2O3 will be. Number of moles of iron in a mixture of 144 grams. See now. So here moles of iron in FeO is equal to 144 grams by 72 is molecular mass is equal to 2. Because number of moles of iron FeO is equal to 144 by 72 is equal to 2 moles. So here 2 moles of iron. Next, moving further, moles of FeO, moles of Fe in Fe2O3. See in Fe2O3 2 iron atoms present, 320 grams, and overall molecular mass of Fe2O3 160. Into 2 we have to do because each Fe2O3 contains 2. So which is equal to, so how many? So here we will get 4 moles of Fe. 4 moles of Fe. So total moles of Fe is equal to 2 plus 4, which is 6. Here 2 plus 4, that is 6. Next question. A sample of oxygen contains O16, O18 isotopes only with percentage abundance respectively. So with this information, let us see further. First, everyone observe the question. Yes. See now, a sample of oxygen contains O16, O18 isotopes only with percentage abundance respectively. As 90%, 10%, identify the correct option. Okay. So with this, how we need to proceed? See. Here they mention O16. O16 is equal to 90% and O18 is equal to 10%. Average atomic mass given. No, average atomic mass. Okay. So here how we find average atomic mass? Average atomic mass is equal to atomic mass of isotope 1, that is 90% here, into atomic mass 16, isotope 1 plus 10% atomic mass 18 by total abundance 100. So average atomic mass here you will get 16.2. Average atomic mass of oxygen. Next. So here now we can consider it as, now if I take it as average 16.2 average atomic mass and then 8, then average number of protons per atom. Average number of protons per atom is, so proton number, here we know protons number, that is constant, average number of protons, because atomic number same it is, protons is equal to 8 only here, that is 8. And then if you see further, average number of neutrons per atom. So how we calculate average number of neutrons? Average number of neutrons per atom is equal to, here 16.2 given, minus 8, overall here getting 8.2. Then molecular mass of O2 gas vary from 32 to, they gave here 32 to 36. Why here 32 to 36? Because molecular mass, what we do here, it is for 16, right? So 16 molecular mass 32. Here if it is 18, here what we can write molecular mass, 2 into 18, so 36. 32 to 36. So it looks like all are correct answers here. A, B, C, D, all are correct answers in this case. Next question. NABR, first everyone read question. See now, I think everyone gone through question. See now, according to given question, these reactions are not balanced. So according to given question, 8 moles of NABR, 8 moles of NABR obtained from 3 moles of iron, 3 moles of iron. How if we balance the reaction? Once you try to balance the reaction, 8 moles of NaBr, 3 Fe3, because 8 Br, right here, Br8, 8 Br, that's why I wrote. So Na2CO3. So if you want to balance it, Fe3O4, 3 iron atoms as it is, 4 oxygen atoms here, 2 oxygen atoms here, so 4 to 6 oxygen atoms. So if I do now, 8 NaBr, so here it is, if I take here 4, so 8 sodium atoms balanced, 4 carbon atoms not balanced. I am taking here 4 carbon. So now 12 oxygen atoms left hand side, right hand side, 8 plus 4, 12, 12 oxygen atoms. So I think balanced. So 8 moles of NaBr required, 8 moles of NaBr obtained from 3 moles of iron. That's what according to balanced chemical equation, we can get this information. Now, so here what we can write now, number of moles of iron is equal to number of moles of iron. So here 1 mole we are getting, so number of 8 moles of NaBr obtained from 3 moles of iron. Yes. So what we can do now, moles of iron is equal to moles of NaBr when 2.06 they mention mass of iron required to produce. So moles of NaBr I am taking here 10 power 3, that is given by 103 into 8 into 3 here. Why? The 8 moles of NaBr obtained from 3 moles of iron. 8 moles of NaBr obtained from 3 moles of iron. So now according to given information, so how to get here moles of iron? See now. So moles of iron is equal to 2.06 into 10 power 3 by 103 into 56 into 3 by 8, which is 420 kg you will get. How you are getting this? Here with this relation I wrote. How I wrote this one? General calculation you can do. Even instead of this, what you can do, suppose if you are confused with this step, do like this. 8 moles of NaBr obtained from 3 moles of iron. So now how many moles of NaBr are given here? 2.06 into 10 power 3 kg. Here it is given as 2.06 into 10 power 3 kg given. So in terms of kg let it be, then by NaBr obtained from 3 moles of iron. Okay. So now how to convert into moles? 103 see 2.06 into 10 power 3 NaBr 80 plus 23, so 103 molar mass. So these many moles obtained from how many moles of iron? I can say how many moles of iron you will get here. So then what we do? 2.06 10 power 103 into 3 moles of iron. 3 moles of iron, what you can add? 3 into 56 by here 8. Directly I showed 420 kg. Answer is 420 kg here. Okay. Next. That's all. These are most important repeatedly asked JEE advanced questions. I hope everyone clear with these concepts. So with this we completed the mole concept series. The first chapter, some basic concepts of chemistry. For basic understanding, everyone should do mole concept properly. If any doubt, once again go through the lecture and go through these PYQs. JEE Mains PYQs we discussed and repeatedly asked JEE Advanced PYQs we discussed. Okay. And stay tuned for next upcoming series. Thank you. Thank you for watching.